Hello, kids. So I think this is our second lesson on vectors. And this is just a little more work with vectors. It's mostly algebraic. I don't think that any of you will really have any issues with this, so this should be fast and easy. So when we look at the problems here, we're given the elements of a vector R, the elements of a vector W, and then we're asked to find the magnitude. That's what these lines mean, the magnitude of the vector, which is R minus W. Remember, magnitude's the same as the length. So what we do is first we find the vector R minus W by subtracting the elements or the components of the vector. So negative 16 minus 4 is going to be negative 20, and negative 7 minus 1 is going to be negative 8. And so now, to find the magnitude, we would do the square root of the sum of the squares of the components. And so if you put that in the calculator, you're going to get the square root of 464. So we have to put this in exact form, which means break it down. I'm going to start with 4 just because I know I think 4 is going to go out of that. Okay, so 464 divided by 4 would be 116. Let's try 4 again. Yep, there we go. So the square root of 4 is 2, and then this would be 4 and 29, and the square root of 4 is 2 again. So the answer here would be 4 square root of 29. All right, question 2. Write vector v in the form ai plus bj, where v has the given magnitude and the direction. Give your answer in exact form. So maybe now is the time to just kind of like go over the formulas that we've done so far. So the magnitude of a vector would be the square root of the sum of the components. Remember, we have tangent of theta is equal to b over a. And then we have the component a is equal to the magnitude of the vector times cosine of theta, and b is equal to the magnitude of the vector times the sine of theta. So that's what we do here. So to find a, which is what the coefficient of I is, we're going to do 10 cosine of 150. And so that would be 10 times. See, 150 is in quad 2, and it is 30 degrees from 180. The cosine of 30 is the square root of 3 over 2. And in quad 2, cosine is negative. And so a would be negative 5 square root of 3. Okay, now let's do sine. And so we're still 30-degree reference angle. Sine of 30 is 1/2. In quad 2, sine is positive, so it will stay positive 1/2. So b is 5. There you go. And there's several problems that are just super similar to that. So in v, or vector v would be the square root of 38 over 2i plus the square root of 38 over 2j. Number 4, same thing. You should get negative 5 square root of 2 over 18i minus 5 square root of 2 over 18j. Okay, so now we're going the other way. We're given the vector, and we got to work it backwards, for lack of a better word, to find the magnitude and the angle. So the magnitude part is fairly easy. Square root of the sum of the square of the components. And so that would be 4 squared plus 8 squared, 80. And so if we break, do we need to break it down? We don't. It says round. So we could have just done this. So the magnitude is 8.94 or 8.9. Now to find the angle, we use that tangent formula. And so theta is going to be the inverse tangent of B, which is 8, over A, which is 4. And again, we're allowed to use the approximate value. So I'm going to go to mode and make sure that I'm in degrees. And then inverse tangent of 2. So 63.4 degrees. Okay, you do the same thing here. You should get 4.0 and 241.5 degrees. All right, a kickboxer picks up a bag with an angle of 45 degrees from the horizontal with a force of 200 newtons. Write the force vector in terms of I and j. So we do the same thing. 200 cosine 45 and 200 sine of 45, and you should get 100 square root of 2i plus 100 square root of 2j. Ship travels 16 miles per hour at a bearing of southwest. So southwest. 30 degrees goes here. Find the velocity vector v in terms of I and j. Give the answer in the exact form. So the only thing here that's a little bit different is the angle we're given is from the negative y to here. But to use these formulas, we need this angle. The angle of the measurement of the entire angle. So that would be either 270 minus 30, or you could say, well, this is 60 less and 180 plus 60. And so it would be 240 degrees. And so then you just do 16 cosine 240 and 16 sine of 240. And you should get negative 8i minus 8 square root of 3j. Kickboxer gives us the vector. Find the magnitude of the velocity vector at the time the ball leaves a punter's foot. Round to, 22.4 squared plus 18.4 squared. Are we rounding? Round to the nearest meters per second. So second square root, 22.4 second square root, 22.4 squared plus 18.4 squared. And we get 28.9882, round to the nearest whole number, so 29. Find the angle. So the tangent of theta would be 18.4 over 22.4. And nearest whole number would be 39. Okay. Given forces, find the resultant force. So the resultant force is the sum of the forces. So for part 1, you're just going to add the components. -5, 17. Now, to be in static equilibrium, that means that we would want our resultant force, or our sum vector, sum of the vectors, to be the 0 vector. And so when you're asked to find the additional force to create this, it's just the opposite of each of the components. So this would be 5, and this would be -17. Okay, you're going to do the same thing here. You just have to add 3 things together. So -12, -8, and 12 is going to give us -8. And then 7 minus 15 plus 8 is going to give us 0. So our resultant vector is -8i, but there is no j. So then the opposite would be +8i. Some books might actually write plus 0j, but most of the time they don't. Okay, so here we have 3 vectors, but we don't have them in I plus j form. We just have the information about them, the angle and the force. So we're going to have to do that for all of these. So for force 1, our components would be 11 cosine 16 and 11 sine of 16. Oops, not a parenthesis. Round all intermediate calculations to 4 decimals. .0320. Okay. Force 2 would be this angle, and all we're given is this part. So this would be 90 minus 44, or 46. So 6 cosine 46, 6 sine 46. So we have 168.0 and 4.3160. And then for force 3, we need this angle, which would be 90 plus 48, or 138. So force of 15 cosine 138, 15 sine of 138. So negative 11.1471. .0370. Okay, so now to find the resultant force, we add the i's. And we get that, and it rounds to 1 decimal place now, so 3.6. Now add the j's. $17.4. And then the opposites. Be careful here because they already put the minus in. So we're still just going to write 17.4. Did they do that on any of the others? No. They just asked us for the components, so we didn't actually write it out. So be careful. Okay. This one is going to be the same thing. You should get negative 28.3 and 38.6. So 28.3. The minus is already there. 38.6. Two forces act on an object with an angle of 69 degrees between them. Find the magnitude of the first force. So this would be your first force, and the angle there is 0. So it'd be 44 cosine 0 and 44 sine 0. And so cosine of 0 is 1. So this would be 44. Sine of 0 is 0. 0. And then the second force would be 60 cosine 69 and 60 sine of 69. So you get 21 point, it says round all intermediate calculations to 1 decimal. So 21.5 and 56.0. All right, now the resultant vector would be force 1 plus force 2. So 65.5 and 56.0. And so then the magnitude would be the square root of 65.5 plus 56. And so you get 86.17. So 86. When we're doing, So I'm not sure why we don't put 0.2, other than the fact that when we're naming, I don't know. You guys probably know this question better than I do. Do they have any leeway in your answers? Meaning if you did put in 86.2, would they count it right? I know in some of the programs there's like a plus or minus where you can be within 0.5, either higher or lower, and it counts it right. I'm not sure about this one. But the answer that's given in the program is 86. I don't see anywhere where it says that you use whole numbers for the final answer. But I will also say that when I'm looking back, I don't really see most of those being with decimals. So I'm not sure if we're supposed to know that. But, okay. Okay, so refer to vectors T, which here's vector T, U, here's U, V, and W. And we're going to pick one of these that's going to end up equaling this vector. So let's start with this, which is u. Here is u. Now this is negative 2u. So u, whoops, this was u. U is going to the left 1 unit. And so negative 2 would be the opposite direction, and we're going to do that twice. So here's 1u, and here's 2. Use a different color. We'll use purple. So here's 1u, and here's 2u's. So here's where this is negative 2u. Now at the tail end of this, we're going to put on negative 2t. So t is directly down. Down would be the positive t, but we need negative. So we're going to go up 2 units. That would be negative t. So then the resultant vector is always connecting the initial to the end. And in this case, it is actually v. So C is your answer. Okay, 16, W, which is here, minus V. So here's our W. We can leave it exactly where it's at. There's no change to it. We need to put on the end of this, though, a negative V. So here is our V, which means that we're going to be going this way. And how far? So we'll go 1, 2, 3, 1, 2, 3, 4, 5. So from here, 1, 2, 3, because I need to go this direction. 1, 2, 3, 1, 2, 3, 4, 5. So I end up here. So the resultant vector is from here to here. So I need to name this using one of these vectors, u, t, v, or w, and make it that long. Well, the only vector that goes in that direction is u. So I know it's vector u. U is only 1 unit long, though, and we need it to be 8 units long. So this vector is 8u. Since we're going in the same direction as the vector, the original vector, it's positive 8u. Even though it's traveling what appears to be in the negative direction on a normal coordinate plane, we're talking about the direction of the vectors. So u's vector travels in the negative direction, which is why we use the positive here, because it's exactly what it's supposed to be. It's not the opposite direction. So that'd be D. Okay, this one starts with V, which is here. And U is here, but we're going to add it. It's 1, 2, 3. 1, 2, 3. So my n vector is here to here. So the only vector that's up and down is t. Now t goes down, I'm going up, so I know it's going to be the opposite direction. Is it the right length? 1, 2, 3, 1, 2, 3. It is the right length. So this is negative t. All right, last one, V. Subtract W. So here's W. I'm going to be going this direction. So I'm going to be coming down here. And I would go 1, 2, 1, 2, 1, 2, 3. Oh, this is going to be weird because V ends in the middle. So I need to go 1, 2, that part's right. 1, 2, 3. So I need to end there, which is at 9. So my resultant vector to the right None of these vectors are to the right, but u is to the left, so it's going to be a negative u. How far? So u is, whoops, 1, 2, 3 along. I'm going out 9, so negative 3u. B. All right, there we go. I'll get it posted.